Hi, and welcome to the Lesson 2 recap. In this video, I'm going to go over all of the vocabulary and main ideas from each of the 4 investigations that you did during Lesson 2. We're going to start off with Lesson 2.1. Now, know that during this video, if we get to vocabulary that you have not yet put into your notes, you will need to pause the video in order to put in the vocabulary definition. I am not going to wait long enough for you to be able to type that. So just make sure that you pause and add the things in that you may have missed during one of the classes. So lesson 2.1 was investigating the motion of a ball. If you think way back to when we did that, that was whenever I was rolling a tennis ball across my dining room table.
1, 2, 3.
All right, so here is a simulated set of data from that situation. If we're looking at the average speed, it's the distance traveled divided by the time it took to travel it. So if we're looking at that tennis ball rolling across the table, and during meter 1, it took only 2 seconds for it to travel, and during meter 2, it took 4 seconds for it to travel, that means that there were different average speeds for those two distances. So the way you would figure that out is for meter 1, you would take that it was traveling for 1 meter, and it took 2 seconds. 1 divided by 2 is 0.5 meters per second. For the second half of its journey, the speed is going to be 1 meter divided by the 4 seconds that it took, which is 0.25 meters per second. So it went half the speed for the second half. Now, these are average. If you took the exact speed at any of the times along the way, it might not be 0.5 or 0.25, but when you look at it for the speed over the course of that entire meter, that is the average of that speed. The other main idea from lesson 2.1 was the description of motion depends on the location of the observer. So if you're on a moving object, the way that you perceive things is going to be different than an observer outside of that moving situation. And that had to do with that whole reading about frame of reference that you had in the assignment. So if you do not fully remember any of that, go back to that lesson and look at it. Our vocabulary that you had was there's quite a bit for 2.1 because it was our first real lesson with a lot of information. So there were the forces, which are the pushes and pulls between objects. When we predict something, we make an educated guess, which is also known as a hypothesis. We looked at the speed, which is how fast something is going. Whenever we're talking about speed as instantaneous, that would require something like a radar gun. We, if you look at the bottom definition, are going to be using average speeds for things, which is where you look at how fast something traveled over a distance and you divide the two numbers. The other thing that we learned about was mass, which is the amount of matter in an object. And since we're using the metric system, we will always talk about that in kilograms or grams. And our final 3 vocabulary terms for this first investigation were acceleration, which is whenever you are changing speed or direction. This can be a speeding up or a slowing down. Velocity is going to be the speed in a single direction of an object. And that reference frame is the point from which you're observing motion, because that will influence how you collect data. We then moved on to investigation 2.2, which is investigating forces. And in this one, you looked at a tennis ball rolling on different surfaces. So there were some main ideas, 2 main ideas actually for this one. The first was that net forces on an object are the sum of all the forces on that object. So if we look at the top of this illustration and you see that there are 2 different forces pushing to the right, one is 60 newtons, one is 30 newtons, then the total of that net force would be 90 newtons. Okay. And if we have a car where 30 of them are going to the right and 10 of them are going to the left, that's going to mean that overall there is 20 newtons to the right because they're in different directions, so you would subtract. The other part of that is that an object's motion can be described from the sum of all of those forces. All right. So based on if this car were sitting still on the top and then these forces were applied, it would start moving to the right. If it were already moving to the left and these forces started happening, it would slow down because the force is going in the opposite direction of the movement. So you should be able to tell things about the movement and the overall forces based off of what the forces are at any one time. The new vocabulary for 2.2 was net force, which is the sum of all the forces acting on an object, and a diagram, which we just looked at, which is a label drawing explaining a situation. It's a kind of model most of the time. The last two of the vocabulary that we had for 2.2 are balanced forces. If you have two or more forces acting on an object that have a net force of 0, then it will not cause a change in the object's movement. Unbalanced forces are when you have two or more forces that produce a net force, and that will cause the object to change speed or direction, which is accelerate. We moved on then to lesson 2.3, which is looking at mass and speed. And this is the one where we were looking at the acrylic and the steel ball rolling down a ramp and then across a flat surface. So, the one issue with the data collected from this lab is that the steel and acrylic ball were moving so quickly, it was hard to catch this main idea based off the data that a lot of you collected. So, I just want to make sure that we make it clear what the results should have been and why they should have been that way. So, it should have been that the acrylic ball was moving with a faster final speed because it was accelerating faster than the steel ball. And the reason behind that is because the acceleration of an object is inversely or oppositely related to its mass. So if we look at our example in the picture here, if we have three different stacks of bricks, one with two bricks, and one with three bricks, all the bricks are the same size and mass, and the force being applied to each of the three piles is the same. That if we have an acceleration on the one brick of 1 meter per second squared, then if we look at pushing two bricks with the same force, it would be 1/2 a meter per second squared. And if we look for three bricks, it would be 0.333 repeating meters per second squared. So as you add more mass, if you're putting the same force into the system, the acceleration is going to decrease. The new vocabulary for this one was that we were looking at variables, which are factors that can influence the results of an experiment. So for the one that we looked at, the variable that we were changing was the mass of the ball rolling. The variable that we were measuring was the speed of the ball. And in our final lesson that we just did, lesson 2.4, we were listening for speed, which was rolling the ball up and down a ramp as it rolled over rubber bands to listen to how the speed changed. And for this one, the main ideas are that the force of gravity causes objects to accelerate. Now, remember, accelerate can be speed up or slow down. So if you are throwing something upward, it is going to slow as it goes up. So it's going to accelerate in a negative way. And as it falls and gravity is helping to pull it towards the Earth's surface, it is going to speed up, so accelerate in a positive way. And with this one, we had two new vocabulary terms, and that was gravity, which is the force of attraction between two bodies, and they don't have to be touching for gravity to affect it, like how our moon has the force of gravity to the Earth, even though they're not touching one another. But also, there's the force of gravity of you to the center of the Earth. And so you are touching the body that you are attracted to in that scenario. The other thing that's happening when you're standing on the surface of the Earth is that the normal force is pushing back up on you, which is that force between a solid surface and another solid object on top of it, so that the thing does not just fall through. Solids don't fall through one another. And that force pushing back upward is the normal force. So if you are standing somewhere, the force of gravity pushing down and the normal force of the surface you're standing on pushing up are equal if you are just standing there and you are not sinking or rising. Hopefully, this has helped to clear up all of the main concepts for lesson 2. There was a lot of information with it being a new unit. If you have any questions, see myself or Mrs. McLean, and we'll be happy to help you.